Hi everyone, welcome to this new presentation of the Śrī Yantra, and particularly a certified atlas of 968 spherical realizations of the Śrī Yantra, one of the oldest and most studied sacred geometry figures. Reconstructed under Rao's 1998 spherical constraint system, every figure is a mathematically certified root, and the viewer displays what was certified. It doesn't compute anything itself. So the atlas presents two layers. The first layer is the layer of certification with 968 roots across 3044 possible constraint subsets, each root verified by Krawczyk interval arithmetic, so a rigorous numerical proof of existence and local uniqueness. And then the second layer I call it gate for metadata, and it has 525 valid and 443 rejected under Rao's registered ordering-containment test. So this is metadata only, and it doesn't affect certification. So this atlas presents 949 drawable figures and 19 degenerate, which are constraints satisfied but figure collapse. So why spherical? As we know, the familiar plane Śrī Yantra is a special case, and Rao showed the constraints generalize naturally to the sphere, producing a much richer solution landscape. Some roots look traditional, and others are widely different. All are valid solutions of the same equations. So just to let you know, early renders used truncated corners, interior construction points rather than Rao's intended produced corners. So this was the same defect that was corrected in plane viewer. And now the spherical viewer uses the corrected topology with the fail-out guard that refuses to emit the old truncated table. Numerical census untouched. So in a nutshell, the spherical viewer is using a corrected topology. And now we're coming to the visual form classification. So in this atlas viewer, you have a filter at the top, visual form here, and we have 5 classification: canonical looking, coherent large gap, near boundary, distorted extreme, and unclassified. So what are those? So a canonical looking are the figures who are traditional plane-like Śrī Yantra. As you can see, these are recognizable patterns, and the others, coherent large gap, figures are domed but balanced, so they take most of the sphere, portion of the sphere anyway. For example, this one, you can see. So in each figure, you can basically click on the figure and rotate to have a three-dimensional view of the Śrī Yantra on the sphere, on a portion of the sphere. And so that's a coherent large gap. It takes most of the sphere, as you can see. It doesn't go beyond the spherical cap. So the patterns which are near boundaries are the ones are looking are readable, but corners go beyond the bounding circle. So they could be like looking like Śrī Yantra traditional looking like, but it kind of, you can see the corners goes beyond the boundary, the bounding circle of the sphere, like this corner, it goes beyond. So I call those figures near boundary. And there's quite a few different type of shape within near boundaries. You can also have spherical kind of coherent large gap patterns, but still going beyond the cap. As you can see, this one could have been coherent large gap, but this not the case because corners goes beyond the bounding cap of the sphere, like this corner. And then we have the fourth classification called distorted extreme. So as the name tells us, these are patterns who are extremely distorted to the point it's nearly, well, it's almost not recognizable of the Śrī Yantra, but these some are still readable and recognizable to the eye, but they are extremely distorted. Like this one, this subset has a very elongated anterior triangles. We can say this is pretty much this, well, the Śrī Yantra. We can barely see it, but still, but it's elongated and quite distorted. Then we have among the distorted extreme as well, some are very much having they are the boundary of a complete structural collapse, like this one, for example. We nearly see nothing. There's only just one or two triangles. Then it kind of, the lines are being pushed to the boundary cap of the sphere. So that's for distorted extremes. And then the last classification, unclassified. I call them unclassified because they are genuinely ambiguous, and most of them have structural collapse. Nothing is left of the Śrī Yantra really. So have a look, explore the atlas. You can click on each. So these are viewer diagnostic, but not certification. The taxonomy was developed through over 400 human reviews, which is me, the first who has reviewed this pattern under 5 classifications. But it's still to be improved. There must still be some errors of classification. Also, I have helped from AI to cross model validation of this classification, and the geometry audit that discovered produce corner that can legitimately exceed the cap boundary even on gate for valid roots. So the models can only get to where they can go to. They're not perfect, and in terms of visual, it's very hard for the models to be exact. Same as us as human, we have difficulty to sometimes to diagnostic, and these 3 Yantra patterns are quite genuinely hard to discern through 5 clear classifications. Well, the traditional canonical looking is fine, but some of those are basically edge cases between near boundary and coherent large gap, or some are edge cases between distorted extreme and unclassified. So yes, it is still an ongoing kind of research in terms of classification, and it will require more refinement on that level. So what can you do with the viewer properly, really? So you can browse all of the 949 drawable figures. So each is a fully rendered spherical Śrī Yantra that you can rotate. So I'll click on that one. in 3 dimension, zoom in on and expect. Okay, you can zoom in on and expect. And the viewer includes filters so that you can narrow down what you are actually looking at. So you have a gateful filter. Also a gateful filter. If we come back to the home page, here you've got a gateful filter. So it shows only figures, the valid ones show only figures that pass Braille's ordering-containment test. So that's the valid ones. That's what you see valid. And some are also rejected. Those are the ones that failed the ordering-containment test. So gate 4 is a mathematically check to ensure the figure's base points remain within bounds. It's basically metadata and doesn't change whether a root is certified. So and you have the visual form filter, as we saw. The visual form filter show how they actually look. Canonical looking, which traditional plain light, coherent on large gap, domed readable, near boundary, corners extend beyond the bounding circle, distorted extreme, rectangular collapsed, or unclassified, which is ambiguous figure. So these are exploratory labels, no mathematical verdicts. And then we have the constraint search. The constraint search. So if we go to a canonical looking valid, let's take this one. So every figure is derived from 6 constraints selected from a set of 20. So F1 to F20. Okay, these are the equations described or developed by Rose in his own paper. So you can search by individual constraint number or by subset patterns. So what can we do? This is here in subsets contains, so 1, 2, 3, and you find figures that share specific combination of constraints. So you see all the subsets starting with 1, 2, 3, and then if you want to only see the subsets who share, for example, a constraint among the 20 constraints. So for example 13. So that's all the subsets who have an active constraint F13 in among the 20 equations. So you can see F13 is present. So you could do from 1 to 20 constraints. So you can choose which active constraints you would like to see for the subset, the relevant subset you're looking for. What kind of subsets are actually actively using the constraint 14, 13, or 3? You can choose in that filter what the particular patterns. Then you can rotate in 3 dimensions, switch between oblique, cap normal, chord skeleton views at the bottom. So what are those? So if you click on cap normal, it kind of takes you to a view from the top, and you can see, so it's centered. You can see the pattern from the top. Then reset view is only if you actually rotating, clicking, and maintaining the view of the Śrī Yantra. If you look at the three-dimensional view and you want to come back to the original view, which is the cap normal, then you click on reset view and it takes you back to that. And then we have code skeleton. So what is that? Code skeleton, basically, it gives you the skeleton of the Śrī Yantra figure. So you can see it, how the line looks like in 2 dimensions, in the projections on the plane. So you can click any edge also to reveal the supporting red circle of the Śrī Yantra. So if you click on that, for example, on an edge, you can see, you have to go back, zoom out to see the whole sphere, basically. And then if you click on one of the edges, you can see the red circle supporting this edge on the sphere. Then you've got, you can view the active F1 to F20 constraint to each figure, as we saw. You've got the mathematical values, the basic variables in radian. So that's basically the numerical values for the solutions of various equations. You've got the derivative values R and A, and then you've got a knot as well. On each figure, you've got a particular knot, which is helpful. So what this is not, this atlas, it's not an absence of theorems. It's got 2,130 subsets remaining unresolved at current search depth. So there is a limitation as well, because it's a rich space. There's a trillion basically solutions to search. It's difficult numerically to prove. There is no root or no solutions in such large space. It's like looking at the ocean and see if it's like trying to measure the ocean, really. It's not impossible, but it's just very difficult. And it'll take probably more advanced computational tool to prove there's no root solution. So, and it's not a claim about which figures are real Śrī Yantra in any traditional sense. The visual forms labels are not certification. They are exploratory diagnostics with documents error bounds. So where does he live? The live viewer is displayed on this article and the data set as well. So everything is open source, MIT license, reproducible, and integrity checked. So that's it for now today, and that was the presentation of the Spherical Śrī Yantra, the certified atlas. It's a massive milestone, and yesterday I have published my paper on Śrī Yantra plane census, which has been submitted to a journal the IJHS is the Indian Journal of History Science. So this atlas here presented is the certified atlas of the plane Śrī Yantra. As you can see now, the figures have got the correct topology. So the plane census paper was submitted yesterday to the IJS and the journal, and the corrigendum paper is currently peer-reviewed with the same journal, the same lineage and the rows, yes, so there'll be future work. I've got 3 papers in the pipeline for the spherical Śrī Yantra. There's one paper which is a paper more actually validate the bridge from the plane to the spherical census, and I've got another paper which has a complete demonstration, a complete proof, maybe even a new theorem for the bridge itself. And then the last paper will be the complete enumeration of the spherical census, which is the one supporting the spherical atlas. Okay, so 3 spherical papers, and it will be submitted to a different journal. Yeah, that's it for today, and hope you enjoyed the exploration of the Śrī Yantra, either for the plane or the spherical. If you have any question, please let me know. Then yeah, enjoy this exploration, because it's a first, and no one has even get up to that point, numerically rendering spherical Śrī Yantra under Rao's equations. So the key was to correct his equations first, which was the purpose of the corrigendum, and from that everything's streamed down to numerically find those solutions, and then renders the figures, create an atlas for the plane and the spherical. So there's been a lot of work, intense research for weeks, and I've been helped with obviously AI models to do the coding, the numerical output, and yes, it has been a project I had to projects, because it's 2 different projects, the plane and the spherical. 2 projects I had to hold together to make it mathematically logical and coherent all the way through. So I'm very happy with this, and I hope you enjoy your day, and I'll see you another time for more work and research. So that's close the loop for the Śrī Yantra for now. Thank you very much, and see you another time.